let's see. So the stuff I'm going to present on today is not, it's not going to be research that's set in organic, certified organic systems, but the lessons learned from these trials I think are incredibly applicable in terms of applying to your production system, especially if you're, obviously if you're an organic grain producer. I think that there's a tremendous benefit to figure out how to incorporate more legume cover crops in rotation. And so what I'm going to present here is I'm going to go through a little bit about some different cover crops and then show some data on how we've quantified these benefits. So actually, first I'll mention that there's been a lot of different researchers that have contributed to this type of work in Wisconsin. And so the data that I'll present here is really the bulk of our information of research trials in the state. If I go like, so I have to use the pointer on both sides. Okay, cool. Okay, so when we think about cover crops, the way I always describe them, we're going to break it down into three classes. And the three classes of cover crops really reflect this idea of the carbon to nitrogen ratio. So we talk about the grass cover crops. We like the grasses, right? The winter rye, annual ryegrass, oat, barley, triticale. They grow quickly. They're one of the best we have at our disposal. We want quick soil coverage, right? The problem is some of these survive the winter, so we have to terminate them in some way. So we're going to have to figure out, we're going to have to go in and terminate mechanically. Oats or spring barley, winter kill, so there's a little bit of benefit to that. They scavenge a lot of nitrogen, that's good. So these are very popular in our dairy-based cropping systems where we may have a lot of excess nitrogen in our cropping system, in our soils. But the drawback to these is that they have a high carbon to nitrogen ratio, and I'll talk a little bit more about that, but we want to remember that these have a bit higher carbon nitrogen ratio. The second group that I like to talk about are brassicas. And so this is your turnip, your mustard, your radish, right? So the radish has been very popular. They're a bit slower to establish though, right? So they're not going to be as fast growing as those grasses. So you're not going to get as quick soil coverage. If you're looking for erosion control, it's going to take a bit longer to establish. All right, so go set and get the mood lighting in here, good. And these have, but once these get going, they can take up a lot of nitrogen. So even though they're slower to establish, by the end of a growing season, they can take up quite a bit of nitrogen. They have what I'm going to call a medium carbon nitrogen ratio. So in the end, these are ones that we're not going to, when we talk about a medium to high carbon to nitrogen ratio, we're talking about a cover crop that's not going to supply nitrogen. It's mostly going to sequester it. Then we get into the legumes, right? Red clover, berseem clover, crimson clover, hairy vetch. They are slower to establish compared to the grasses. They fix nitrogen from the atmosphere, right? So it's not reliant as heavily on the nitrogen supply from the soil. It has that symbiotic relationship with the microorganisms, right, that fix nitrogen from the atmosphere. And it's got a relatively low C-to-N ratio. So when we talk about these benefits and these nitrogen supplying benefits from the legumes, part of the benefit is from the fact that they fix nitrogen from the atmosphere. But in reality, but the main thing is it has this relatively low carbon to nitrogen ratio. That's why it ends up supplying nitrogen. So I have this very simple description of why the carbon to nitrogen ratio matters. And so if we look at this brown square here, let's say that represents the soil system. What's going to happen first? So in the green here is the green box represents a cover crop biomass. So here, this is going to be a cover crop biomass that has a C-to-N ratio of greater than 30. This would be like a rye cover crop biomass that we've tilled into the soil. What's going to happen? Am I really tethered to this? I can't move around? Okay, I like to wander, but that's okay. I'll try to stay here.
Roger.
I'll try to stay here. All right, so I'll try to work off both sides here. Anyway, okay. So in the soil, you've got the blue here, so that's nitrate. You've got ammonium, so those are the plant available forms of nitrogen. So we have this cover crop biomass for that. The first thing that's going to happen is what the soil microorganisms are going to work to break down that plant material, right? But in doing so, they need to consume nitrogen to fuel themselves in order to facilitate that breakdown. But at the end of the day, what's going to happen is that it's going to require more nitrogen from the soil to break down this plant material relative to what's going to be the nitrogen from this plant material is going to be put back in the soil. So the arrows are going mostly to degrade the cover crop, and then the cover crop, when it degrades, isn't releasing much nitrogen. So there's less net nitrogen in this system over a short period of time. We call that a mobilization, right? For those that remember their soil science. So the microorganisms first always need nitrogen. So that's why over the short period of time, these rye cover crops, they can tie up some nitrogen. But now if we have a cover crop that has a lower seed-to-end ratio, less than 20, what's going to happen here? There's nitrate and ammonium in the soil, so the microbes, the first thing that's going to happen, they're going to use that, start to break down the plant material. But since there's more nitrogen per carbon in that plant biomass, when this starts to break down, there's a lot more nitrogen left over, right? So after the breakdown process, it releases a lot of nitrogen. So the microorganisms end up, there's more there than the microorganisms could need. Thus, there's more nitrogen in the soil for the plant to take up. And so when we think about the nitrogen supplying process, it's all about this carbon-nitrogen ratio of where's that nitrogen going to be? Is it going to be available for the plant, or is it going to be tied up in microbial biomass? And then so when we talk about this medium, these are a bit arbitrary numbers. The 20 to 30 are a bit more rule of thumb type numbers. But if you got that 20 to 30, then we say that's relatively balanced. The amount of nitrogen that's consumed by the microorganisms to degrade the plant material is relatively equivalent to the amount that's released by the plant material. So that's sort of a system in balance where there's no nitrogen tie-up, but there's no nitrogen availability either. And I'm going to go through, so if you remember, this cover crop, those are the grasses. And so I'm not going to show any of that today. I do have a lot of research and presentations on the fact that there is some potential tie-up of nitrogen with these cover crops. Not detrimental to our agricultural systems, but over a short period of time, when you think about it, is going to take some nitrogen away. So we may have to supply a bit more in those systems. I'm going to talk primarily about this and how much nitrogen is potentially released. And then so this is the clovers, and then this would be the radish, and I'll show just a little bit of data at the end on what a net neutral system looks like. So with that, let me go this way. We've got several studies around the state where we've been evaluating, we've been working to quantify this nitrogen benefit of the clovers. And I should actually, so we've got red clover trials that have occurred in the southern part of the state, in Columbia County and Rock County. We've got berseem and crimson clover and radish studies that have occurred in Sheboygan and Washington counties. And these are cover crops and systems that, if you have winter wheat in rotation, they're going to be very easy to plant and grow. So these are always systems that are typically a corn, soybean, winter wheat system where these cover crops are being planted into or after that winter wheat phase of rotation. So having small grains, the value or the ease of getting these clover cover crops established is really tied to having small grains in rotation. So if you've got small grains, then you're going to be able to do it. So if we think about our conventional systems, where if it's continuous corn or corn soybean, there's not as much opportunity, or you have to be a little more clever, or we have to do some different things that are maybe a bit more cumbersome to try to get these in. So in any case, I do acknowledge up front that it is tied to this winter wheat. Now, most of this research has been funded by the Wisconsin Fertilizer Research Council, and I think that's pretty great because this is, in a sense, looking at other alternatives to fertilizer. And so they've been very supportive of all of this cover crop research. So the first type of system that I want to talk about are these frost-seeded red clover. So if you've got winter wheat, if you plant winter wheat in the fall, you come around in the spring, what we want to do here is we're going to top dress red clover into winter wheat. And so we're looking for conditions where the snow's melted, the soil is relatively dry, maybe has a little bit of cracking in there. You're going to top dress the red clover right over the top. And what's going to happen is then that clover is just going to get established. It takes a little while for it to establish. That wheat's going to take off, and that clover is just going to hang out in that understory. And so a system would look like, mid-March, anywhere between mid-March to mid-April. You're gonna top dress about 12 pounds of red clover. Then in late July, you're going to harvest that winter wheat. And then in early mid-September, you may have enough, we've seen this happen where you have so much biomass we end up going back and we clip it back. We mow it down just to get that plant material to remain and make it manageable for the fall. Then in our conventional systems, we've worked in a system where we feel we have enough biomass that we're gonna terminate it in the fall. But there's an opportunity also, if you're interested, you could let it keep growing into the spring. It'll survive the winter if you want to try to grow more nitrogen. So in any case, in the context of these studies, we've terminated it in the fall. And so what you can see here, so this is what it looks like around when it's getting time for wheat harvest. That clover is just hanging out in the understory. But that's all we need. We just need it to get going, because clovers takes a while to get going, but we've saved so much time by getting it going right now, right? So then looking at a field then in a little bit later after harvest, at this point in time in the growing season, so this is into the fall, on the right side is the clover. We've got 100 pounds of nitrogen in that above ground biomass. That's not available nitrogen, but it just shows how much nitrogen we've grown over there. And what you'll notice on the left side is where we didn't have the clover, right? And so we have a lot of volunteer winter wheat, right? This is pretty common. And what we don't have is volunteer winter wheat in that where we planted the clover. It helps choke it out, right? So we're getting that suppression benefit. Now, the trade-off is that we're gonna have to go terminate it as well. Another just sort of view into that field, we take these biomass samples, we can kind of see into the stand. It's a nice, thick, dense stand too. So it doesn't have to be tall. So it's not that tall. How is there that much nitrogen in there? It's a really dense stand, and we see this quite often with these clover stands, right? For those that have tried it. So you get a lot of nitrogen. You don't have to get the growth in this direction. You want the density in that plant, in that crop. In any case, the one thing is, so we do see a little bit of, we can see some regrowth that next year too. So it's hard. Sometimes we have to. The challenge may be making sure it's dead. We don't want it to become a weed to the next crop either. So as we talk about this quantification, we have to talk about the way we're quantifying it. And it's a bit academic, but I think it's important to mention, because all of these slides are going to relate to it. So nitrogen credits, to know there's a nitrogen credit of something. If you're doing something and it means that you can apply less nitrogen to optimize yields, how do we quantify that? We have to do it through use of these response curves. So what we do is we follow these clover cover crops, we follow them with a nitrogen rate trial on corn, right? So the next crop is going to be corn. We're picking corn because it's a high nitrogen demand crop, right? We're looking to supply nitrogen. But so what we have to do is, so here's an example of the types of response curves you can see. So you can have a response. Let's assume the x-axis is, can I do this? No? These are fine. Hey, there we go. So on this side, on the x-axis here, would be a nitrogen rate, and the y-axis would be the yield, right? So you can get a response like this where it's linear. This would imply rates keep going up. But usually what we do in these studies, we put out rates that are way over application. So we're expecting yields to top out at some point. But it's really important that historically you'll see a lot of quadratic response curves. So that means that the yield goes up and then goes down. But in reality, biologically, it's these plateau curves that are going to be the most biologically correct in many cases, especially for corn, where yields are going to go up to a certain point and then there's not going to be any more response to nitrogen. But we're not also working in a level where we're applying so much nitrogen it becomes detrimental to the plant. We're not in that sort of range. So statistically speaking, you're going to see a lot of statistics here that are going to be plateau curves. And that means that yields go up to a point and then plateau. The other aspect of this, it's really easy to identify where the optimal nitrogen rate is, right? So it's right at that inflection point. So if we can start comparing these systems, it's really easy to interpret. So in any case, I think it's just to explain what you're going to see next are going to be plateau curves. Okay, so here's a study from 2010. This was in Janesville, and this is really this was the one study that we were using in all of our extension talks for quite a while. But it was an amazing trial where we saw. So this is that frost-seeded red clover, and then we follow that. This is the corn that's grown the year after, right? So the red here is our corn yields following no cover crop, and the blue is following the red clover. So there's two things that are happening here. So I'm drawing the plateau lines, where the yields plateau. So the first thing is we got a yield bump, right? So there is also this benefit to these clovers in rotation for breaking up what amounts to being a grass on grass, weed on corn cropping system. So having that clover in rotation in there is functioning to benefit the rotation. So we get a rotation effect that gives us a yield bump. And here we've gone from 176 to 203 bushels. The other thing is we want to look to see where these yields start to plateau. So in this case, using these plateau curves, we calculated a 46-pound nitrogen credit, meaning that yields were maximized with 46 pounds less of nitrogen following a red clover cover crop than without. So all of that biomass that went into, that was incorporated, we had 42 pounds of that was available to that next plant. We're also getting tremendous yield benefit even if we're not applying any nitrogen. So I didn't do any economic calculations in this system, but if you're looking at this, it might be economical to not even apply any. The clover may be supplying plenty of nitrogen to that system. So it's this dual benefit. Okay, so we had this data for a while. Is this universally true? Would we continue to see it? Well, I'll also mention this one thing. The other thing that we measured in this study, we looked at the nitrogen in the fall, and then the nitrogen that next spring. And so in the fall, with no clover or red clover, this is in the first foot and the second foot, the clover is taking up excess nitrogen. So it's not that the plant, it's still functioning as a plant. It's not fixing all of its nitrogen, right? It's still going to take up some nitrogen. So in this system, it's reducing that soil nitrate in the fall down to negligible levels. But here's what happens, right? When we terminate it and that plant starts to decompose, this is exactly what we'd expect to see. This is a pre-side dress nitrate test. So what this is the nitrate in the soil around the time of when the corn's about 12 inches tall. And you can see that the amount of nitrate in the soil is doubled but we haven't applied any nitrogen yet, right? That's just how much, that's just from the release of that plant material. So it's the both things are happening where that red clover is taking up some nitrogen, but because it has that low carbon to nitrogen ratio, boom, we've got this big flush of nitrogen. This is going to be available for that corn plant. That explains why we're seeing such large yields without any nitrogen applied. Now, sometimes we get the question of why do we recommend planting this frost seeding planting over just planting after winter wheat harvest. So for red clover, there was this simple planting trial in Dodge County, and this is from October 1st of 2013. So on the left is red clover that was planted after winter wheat harvest, and on the right was red clover that was planted that was frost seeded, right? So getting something planted in March, even though it just hangs out in that understory, there's not a lot of growth, just getting it established provides that much more biomass. You can see here, the clover isn't even above the wheat stubble yet, but here all the clover is well above the wheat stubble. There's an advantage. If you're looking to grow nitrogen, there's a huge advantage to getting that clover growing early. The other studies we did were related to berseem and crimson clover. So these are ones where, okay, red clover, we have to go in, we have to terminate. That's an additional expense, it's an additional time in the field. Do we want to mess with that? Can we get the same kind of benefit by just growing the berseem and crimson? This will get planted following that winter wheat harvest, let it grow, and then let it winter kill. Let's see what happens. So we worked with a farmer in Sheboygan County. We planted these cover crops on August 15th in 2014. We planted them both at 15 pounds per acre. Now, I'm not sure we have the exact rate dialed in. You know, in the red clover, we put it at 12. This we did 15. In this case, we're drilling it in, so it's possible we could taper back a little bit. But this ends up being what we used. And we compared it to no cover crop. So it grows in the fall, winter kills, and then we plant corn the next year and see how much nitrogen was released. So crimson clover versus berseem clover. So has anyone worked with crimson clover before? And what about berseem clover? Well, more on the crimson side. Okay, interesting. So in this field, I would say the crimson versus berseem, there were some differences here. I mean, certainly in the amount of growth. We had decent growth, but it was a little bit patchier. It was relatively patchy. Now these are some heavier clay soils. They had gone through it. There was a little bit of, a fair amount of traffic in there, so we had maybe some compaction issues where things weren't growing as well. But we see a little bit of patchiness and not as tall of growth. But in the end, we had 47 pounds of nitrogen in that above ground biomass, and the seed-end ratio was 16. So again, another example of a low, But the berseem clover, I liked it just from a visual standpoint. I liked it a little bit more. The growth was relatively consistent. There was less patchiness where we had planted it. And it grew, and this year it grew a little bit, it grew taller for sure, but that's just sort of how it grows. But also there was just simply more nitrogen. So here we had 75 pounds of nitrogen in the above ground biomass with a seed-end ratio of 14. And we had about 14 inches of growth. So the berseem will grow a little bit taller, but it's a little bit wispier as well. Now, the other thing I like, we're also concerned. We're trying to get everything we can out of these cover crops, right? And so we're trying to make sure that we can still have that soil coverage. But if it's gonna winter kill, do we have enough biomass? Now here's what the berseem clover looked like that next in one of the springs. There was a lot of dead biomass coverage. I actually like this quite a bit. But when we compare that to the crimson clover, there wasn't as much biomass. The way it looked like it was breaking down a little bit faster, there wasn't as much soil coverage. So there's maybe a little bit of trade-off between those two. What about nitrogen? Did it supply nitrogen? Okay, so in this one we've got 3 different colors in here. So the red is the no cover crop, and this is the response curve. This is what yield looked like. So interestingly, and I just was railing about quadratics aren't appropriate, but sometimes even when we apply up to 300 pounds of nitrogen, we're still going up. So that's just the scientific world sometimes. But this is the response curve, all right? But we can have this to compare. But when we grew we're looking at the blue here is the crimson clover. Here's where the yields plateaued. So we had a slight yield bump in terms of maximizing yield at the end. But if we believe these statistics, 168 pound nitrogen credit, right? Well, that's certainly more than that was in the plant biomass. But it does demonstrate that there is a clear nitrogen credit. I don't know if it'd be 168 exactly every year, but you can see that yields start to plateau out here. Tremendous benefit, especially if you're applying in these more reasonable ranges. You're going to see a yield benefit and a clear nitrogen credit. Now the berseem clover. So the crimson clover, and I was just commenting that the crimson clover didn't grow as much as the berseem clover, but it didn't matter. We got a tremendous benefit from it. But when we look at the berseem clover was acting a little bit goofier here with its response curve. But there's 2 things to look at. One is the berseem clover had huge yield gains with no nitrogen applied, but the crimson clover didn't. Interestingly, so there was plenty of nitrogen being supplied that it was increasing yields. So the other thing is, but when we look at where the yields plateaus are, there's bigger yield benefits we saw from the berseem clover, but there weren't as big of nitrogen credits exactly. So we had a little bit of a trade-off because where this started to plateau was sort of out here, so there wasn't as big of a nitrogen credit determined. But interestingly, on these soils, if we use, and I don't know how many of you use any in-season soil nitrate tests. They're okay, but you have to accept things like this are going to happen. So we saw these big nitrogen benefits in responses, but we never picked it up in the pre-sidedress nitrate test, unfortunately. So here's the pre-sidedress test here. With no cover crop, it was 8.6. Crimson clover 5.3, berseem 8.7. We would expect those cover crops to have much higher values to show, hey, there's a lot of nitrogen there. There's a comment?
At Cornell, we found the PSNT way understated the benefit of clover.
Excellent. Okay, good. That makes me feel good that my results are.
What was the comment?
Oh, I'm sorry. Yeah. So at Cornell, if you can believe what they say at Cornell, of course.
They're a competitor, I'm sorry.
No, Cornell was. They were saying that they found the same thing, that the pre-sidedress nitrate test was under calculating the nitrogen credit of the clover.
But by a lot, though.
By a lot. And so this would be exactly in that line where it's not showing any crediting based on the amount of nitrate that exists at this one point in time. And that's always going to be the drawback of trying to of measuring nitrogen, right? Because it's only getting, the nitrate is real transient, right? It only exists as nitrate at that one time. But if this, a week later, a flush of nitrogen could have come through and there have been the big gains, right? So we don't know. We don't know. I know I'm going way over on time, but I'll wrap this up.
Won't the yield get rid of all that questions?
Yes, so we have to have these response trials to calculate. So what I'm saying is that I think we're gonna at the end we're gonna have to rely on experiments like this that are using response curves to show the nitrogen credit based on yield, right? Rather than relying on in-season tests. So at some point, I think we're gonna have to run a bunch of experiments and then trust that this you have to believe in the experiments basically over the side dress nitrate test. Does that make sense? So the good news is we did this study again, and we saw a lot of the same thing here. This is the berseem clover. This is the crimson clover. So the berseem's a bit wispier, always a bit more biomass, but we had good growth in the second year of this trial with both of them. They always nodulated. I always dug up the plants to make sure they nodulated. This is what a no cover crop plot looks like. So there's a lot of other things that these clovers may be doing. Just getting roots in the ground could just simply be helpful on these heavy clays that, where you have this traffic occurring. It can be alleviating some compaction and getting some roots in the ground. But the same sort of effect. So the red line where it says 210, that's the no cover crop. The blue line is the crimson where it says 208. So basically no effect on yield, but a big nitrogen credit. The berseem clover in the green, we got that yield bump, but not as big of a nitrogen credit. So interestingly, we calculate a 46-pound nitrogen credit with the crimson, but only a 15 with the berseem. But we got a 13 bushel yield increase with the berseem. So I
think is the yield better?
I don't know.
Than the berseem?
I really don't know. In reality, from just the visual data, there's more biomass there. There should be a bigger nitrogen credit from the berseem. Comment.
That has anything to do with the biology of the different plants in terms of how the soil bacteria is reacting to each variety to get that in terms of the mobilization of those minerals?
Yeah. So the question was, is it something to do with how the biology of the plants or the way the microbes are breaking down the plant material? And I don't know. You would think that these are both clovers; they would be similar enough. They're both relatively low in seed-to-end ratio, so I can't provide a clear explanation, but it's, we run these trials like this and we see, but in any case, we are seeing these nitrogen credits. They're real. I think we do need more trials in these systems. I'd like to have it in different systems to quantify it. Comment, question?
What test were you using to calculate your above ground nitrogen in the summer, and then did you go back and take the dead plant material and do the same test on that in the following spring?
So the question was how we calculated the nitrogen. So the nitrogen content of the clover that I'm showing here is calculated right before winter kill. So we went out, basically just watching weather reports. We got it. We felt we collected those squares, collected all the plant biomass and the above ground biomass. So it doesn't include any below ground biomass. So it's not that. So there's probably another 20, 30, 40 pounds of nitrogen probably in the roots as well. And then in the dead biomass, we didn't attempt to do any coverage there. So we're trying to capture the nitrogen release through these response curves.
It
Comment,
looks
question?
like you're getting a fairly early release because of the winter kill.
Could be.
The possibility that these modern corn hybrids needed a bigger bump of nitrogen when they were at the B2 to B4 stage. That shows in the berseem, but there wasn't the carrier.
That could be it too. And so in this trial, I'm sorry. Yeah. So the comment was, is the release of the berseem too late?
Or is it early? Earlier?
Is it having earlier, and then thus it's maybe not?
And then running out.
That could be it as well. So it's the release patterns, right? So that's another thing to delve into. So So everything that is here is contingent on the way that the study was conducted, right? So there was a little bit of nitrogen in the planter, so at starter. And then the remainder went on at side dress, so around when the corn's about 6 to 12 inches tall. So that was the system that we were working in attempt to capture this, right? So if you do another study where you start changing the timings of the nitrogen or stuff like that, you might get different results. You might quantify nitrogen credits differently. And that's a fair comment. So, but I think in the end, what we have, and I'll just kind of cut right to the end here, we have 6 site years of data now in Wisconsin to calculate this nitrogen credit. And so we've got 2 for clover, 2 for crimson, 2 for berseem. We got this 168 pound in here that's skewing it a little bit, but again, we also calculated 1 year a 92 pound credit for the clover. So, which also could be things that are happening that aren't related to nitrogen too, if that's a whole other story. But on average across all these studies, we're seeing a 68 pound nitrogen credit and an 8 bushel yield advantage by having a clover in rotation. So over these 6 site years in general, we're seeing everything in a positive direction. The exact amount of nitrogen that's going to be credited will vary. 1 year we only got 15, but for most of them we're about 40. I think you can get. I think that if we continue this, I think the goal would be if we can try to get at least 40 pounds of nitrogen, that would be beneficial for your cropping system.
I'm really curious about that with the berseem clover nitrogen credit. Just the bushels per acre advantage is 15 and 13.
Yeah.
Fascinating to think of what else is happening.
Exactly, and these were just relatively simple trials, right? And so I think that there's a lot more interesting science to do to capture it. But I think we also, just from an applied standpoint, we need more of these types of trials as well.
Well, would the solution be to plant a mixture of the two?
That's a good question. There's comment, what if you applied in a mixture of the two? I don't know. Probably, right? Well, the thing is, if one starts out-competing the other, because they have different plant heights and growth patterns, would that choke it out? I don't know. Something to play with. All right. He's going to work on it, and then he'll get back to us. But that'd be interesting. In any case, so the only other thing was that this idea that this yield bump with the legume cover crops is well known. There was a review study that was done, and this is the yield. They looked at 68 studies, and this is for grass cover crops. And this is relative yield change using a cover crop. So with rye cover crops, the majority of the studies published prior to 2005 showed a negative effect on yield. So a lot of times coming from a nitrogen tie-up. Here, for the legumes, we typically see the effect is positive. So this is what we're seeing is also generally true. Comment, question?
Do your clovers never overwinter?
So the question was, do my clovers ever overwinter, or do these? Right. So in these studies, we didn't have any overwintering of berseem or crimson. I've heard comments that others have seen that.
Overwinters in New York.
The crimson?
At least in a warm location in New York, it will overwinter.
It will overwinter. So
5 hours south, it'll overwinter.
5 hours south, it may overwinter. So you want to be as north as possible. Fair point too, right? I mean, so everything's geographically located, right? So these are a couple hours north of here still, so even a little bit cooler conditions. So we're always seeing winter kill in these plots. Just last thing that I'll just show here, instead of going to my diatribe, but the radish. So I was hoping that the radish would supply nitrogen as well. There's a lot of nitrogen tie-up. Right, there's a lot of nitrogen in the biomass. The seed-end ratio isn't quite as small as the clovers, right? So it's what we're calculating is more in the 20 to 24 range, but a lot of nitrogen tie-up. It winter kills too, right? So, and here's a field of radish. Here's a field without the radish. So again, the same thing where you get good soil coverage. You choke out the winter wheat, the volunteer winter wheat. But when you look at response curves. Click, oh no, circle, that's okay. This is not really, there we go. And you see this exciting data. The response curves are right on top of each other, right? So the black dots are not following a cover crop and the white are following the radish. This response curve is right on top of each other. So there's no nitrogen credit. We did this, we had 9 site years of this data. We saw the same thing every single time. We never saw the nitrogen that radish that was being released to supply nitrogen to the corn. So it's either decomposing really quickly and maybe going through those root channels and kind of moving out of the root system, or it's not releasing it fast enough, but or maybe some sort of combination of the two. But in any case, it's not being captured by the corn crop. Was there a comment or question over there? Okay. So with that, I think that that's what I got. So in summary, you're going to get a credit if you can figure. The main thing is, I think it's a huge system, a huge advantage to all of our grain systems in the Midwest. Is how do we get more legumes into this rotation, and not soybean. We need actual plant biomass legumes, right? So that's a grand challenge for all of us. And I don't know if I have any more time for questions, but I'll be around still over lunch a little bit too.